Welcome to the Tower Focus Learners. You have just stepped into today's Elite Explainer simulation. I am your Tower Director, and right now we are dealing with a massive, high-stakes situation on the radar. We are targeting a highly specific, critically important incoming heavy aircraft. Cambridge Mathematics Syllabus 9709, Topic 2.2, Solving Logarithmic and Exponential Equations. Whether you are tracking this sector for the absolute first time, or you are a seasoned controller, fine-tuning your approach vectors right before paper day, listen to me carefully. This is your examiner blueprint. We have two trainee routers on the consoles today. Router Alex, who constantly gets bogged down in minor details and creates an infinite holding pattern of panic, and Router Sam, who clears mathematical arguments for landing way too fast without actually verifying the structural safety regulations. Our core objective today: teach you exactly how to manage extreme time pressure in the exam room and prioritize those high-yield method marks so you don't crash your grade. Strap in. Okay, let's look at the radar grid initialization. Here is our flight plan for this sector. Number 1, core exam principles. Number 2, the technical methodology. Number 3, securing your method marks. And number 4, critical examiner warnings. Before we get into the exact mechanics of bringing this equation in for a safe landing, we absolutely need to talk about why you are here in the control room today. We have a direct quote from a senior examiner, basically the Aviation Authority of Cambridge, stating, "This topic appears in every examination series." Let that sink in for a second. Look at your radar screen. Mastering logarithmic and exponential functions is not just a polite suggestion, it is an absolute non-negotiable necessity. You are guaranteed, literally guaranteed, to see these questions pop up as a heavy, high-tariff target when you sit down for your exam. Router Alex is already sweating just looking at past papers, and Router Sam is trying to skip the review entirely. Don't be like them. The time we spend today unpacking these concepts is going to directly translate into survival points on your final score. Part 1, Core Exam Principles. Let's initialize the radar grid and see what we're working with. Right, look at the contrast on the screen. The 9709 assessment framework heavily, and I mean heavily, favors analytical depth over superficial breadth. What does that mean in our tower? Well, examiners are not just checking if you have superficially memorized the basic manual, like knowing that log A plus log B equals log AB. Router Sam thinks that's enough to clear a landing. It's not. Top-performing candidates exhibit a deeply connected structural understanding. If you rely purely on superficial memorization, you are going to absolutely freeze up when a question masks a quadratic equation right inside a complex natural log function. You'll put yourself in an infinite holding pattern, just like Router Alex does, overthinking the wrong variables. The examiners want to see logical, structured reasoning. They want to see an analytical depth that holds up and keeps the aircraft steady, even when the weather gets roughed and the mathematical context is entirely unfamiliar. To enforce this structural depth, the Cambridge exam targets 3 distinct cognitive domains. Think of these as the 3 primary tracking instruments on your radar console. Instrument 1 is knowledge and understanding. This is knowing your base index laws inside and out. Instrument 2 is application. This is actually applying those exact laws to manipulate an exponent or bring down a power under heavy pressure. And instrument 3, the most critical one, is analysis. This means systematically solving the equation and having the situational awareness to reject invalid routes. The examiners use these 3 cognitive domains as highly specific benchmarks to measure your evidence-based reasoning. If you hit all 3 on your radar, you are locking in a perfect trajectory for top marks. Part 2, the technical methodology, shifting from theory to the exact procedural workflow required under fire in the exam room. Okay, things are getting tense. We are now routing the approach vector. Systematic processing is your absolute best friend when dealing with complex mathematical problems. Tackling an exponential equation requires a strict, standardized sequence. I'm looking over at Router Alex and Router Sam, and they are completely debating the sequence of operations for their working out paragraphs. Alex wants to jump straight to step 4, and Sam completely forgot step 2. Listen to me, you must follow this layout based on explicit assessment objectives. Step 1. Deconstruct the question to identify key elements. What is the actual threat here? Step 2. Extract relevant data. You need to identify the base, or spot that hidden quadratic structure lurking in the exponents. Step 3. Select the correct analytical framework. This is where you decide, hey, I need to take the natural log of both sides right now. Step 4. Execute with crystal clear algebraic notation. No messy handwriting, no skipping lines. And step 5. Present your final result with correct terminology. Follow this exact workflow, map out your approach layout, and you completely remove the panic from the equation. You control the numbers do not control you. Part 3.
Securing your method marks. The ultimate exam safety net when the system starts flashing amber.
Tower transmission check. Pause the screen right here. Before we clear this response for touchdown, I need to ensure your transponder is fully updated. Subscribe to Ace the Exams, that's at Ace the Exams, right now and turn on all notifications so you never miss an emergency broadcast from this channel. Okay, transmission clear, let's resume. We are looking at the method mark strategy. This is incredibly empowering. It is your emergency glide slope. It's an examiner's scoring mechanism where marks are awarded for demonstrating the correct systematic processing and analytical steps, completely regardless of your final numerical outcome. You are literally rewarded for trusting the process. Let's say you drop a negative sign, or make a tiny silly arithmetic error on line 3 of a 6-line calculation. If your methodology is perfectly sound, you can still salvage the vast majority of the points for that question. It is an incredible safety net for students under pressure. It's what we call the fuel to mark budget. Even if you don't hit the center of the runway, a safe landing with the right approach still keeps you alive. But look at the amber warning lights flashing. There is a catch to the safety net. To secure those method marks, your presentation of information must follow strict conventions. We're talking proper headings, correct terminology, appropriate formats, and incredibly clear annotation of your working. You cannot just scribble a chaotic massive web of numbers in the margins and hope the examiner is some kind of mind reader. We're deploying the formatting template here to guide your mathematical sentences back onto the glide slope. Treat your working out like a formal report. The examiner needs to easily follow the story of your logic, line by line, from the top of the page all the way to the bottom. If Alex sends me a radar log that looks like alphabet soup, I'm rejecting it. Keep it clean. Furthermore, the absolute highest scoring candidates, the ones who truly master this sector, they go way beyond just showing their math. They demonstrate evaluative thinking elements. Oh wait, the crew just encountered an unexpected structural block mid-calculation. What do? Evaluative thinking means identifying limitations and justifying your decisions with concrete evidence. For example, let's say you solve a logarithmic equation and you end up getting 2 values for x. One is positive, one is negative. Evaluative thinking means explicitly showing the examiner why you are rejecting that negative root. You must write down that you are rejecting it because the domain of a log function must be strictly positive. Don't just cross it out silently, justify the decision. Tell the tower exactly why you are altering the flight path. This level of mathematical communication is what completely locks in your method marks and secures the perimeter. Part 4. Critical examiner warnings, transitioning to full alert status as we unpack the most common failure points. I need everyone's eyes on the screen right now. Every single year, the Cambridge authorities publish their principal examiner reports. And every single year, without fail, these reports consistently highlight 3 major catastrophic mistakes that students make when attempting topic 2.2. These are the 3 amber alerts on our radar. Welcome to the interactive runway workshop. We are doing live audience tracking right now. I'm putting a 60-second visual timer on the board in my mind, and I need you to isolate the primary threat variables here. Let's look at the top 3 classic traps you absolutely must avoid. Warning number 1, using the wrong approach for the wrong context. This is when Router Sam tries to force a memorized logarithm formula onto a situation where it simply doesn't apply, trying to land a jumbo jet on a dirt road. It crashes. Warning number 2, forgetting to check format and presentation. Let's call this Assessment 2, Debris on the Runway. You have to find the exact line where a student drops points. Listen, in Cambridge Math, if the question does not explicitly specify otherwise, leaving your answer in exact form or rounding to exactly 3 significant figures is mandatory. It is a structural safety regulation. Ignoring this universal rule leaves debris on the runway and costs you points every single year. And warning number 3, providing answers that are not specific to the context given. If the exponential equation represents a real-world scenario, say population growth or radioactive decay, your final numerical answer needs to actually reflect that physical context. You can't have -3 rabbits. Pay attention to the reality of the math. Which brings us to the final approach, a safe touchdown sequence. The most crucial point of this entire simulation is summarized perfectly by this final vital alert direct from the examiners themselves. Quote, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. I cannot stress this enough. Team, do not, under any circumstances, do complex logarithmic transformations in your head. Put absolutely everything on the paper. Calculate your fuel to mark budget formula correctly, because even if your final answer is completely off base, those meticulously documented method marks are going to completely save your grade. Router Alex and Router Sam have just logged a successful full mark landing sequence because they finally slowed down and showed every single step to the tower. Which leaves us with one final, provocative question to consider as we close down this control tower for the day. Ask yourself honestly, during your solo practice sessions, are you meticulously checking your formats, your contexts, and your analytical steps to absolutely guarantee your method marks? Or are you just rushing to find the right number at the end and hoping for the best? Reflect on your practice habits today. Adjust your transponder to align with these Cambridge Examiner expectations, and I promise you, you will walk into your next math exam with absolute, undeniable confidence. Final command from the Tower Director, hit that subscribe button for AC Exams, that's at AC Exams, enable the notification bell so you never miss an approach vector, and drop a comment down below sharing exactly which paper gives you the most anxiety. We'll tackle it together. Until next time, keep trusting the methodology and keep your mathematical reasoning crystal clear. Tower out.